In the next few lessons, we're going to be looking at Newton's laws of motion. So in this lesson, we're going to look at his first law. So before we look at his first law, we have to talk about inertia, because this law is also sometimes called the law of inertia. Inertia is a property of matter that causes it to resist changes in motion. Basically, the heavier an object is, the harder it is to move. So the more force you would need to move it. And that should make sense to you. So here's Newton's first law of motion in words. An object at rest will remain at rest unless acted on by an unbalanced force. And an object will continue to move at a constant velocity unless acted on by an unbalanced force. So one of the easiest ways to explain this is to think about if you've ever taken public transit, so a bus, subway, something like that. You get on the bus and it's stopped, and then the bus driver or the subway, it starts moving, and you feel that jolt. And what that is it's because your body wants to stay at rest. You were traveling at 0 meters per second. And now all of a sudden, the thing that you are in starts moving. And so your body wants to stay still, but it can't. And so you feel that jolt. Same thing happens when it comes to a stop. So this is actually an animation. So if you were in class, you would have seen that animation. So what happens is the car hits that wall and the man comes out of the car. And that's again because he wants to continue traveling, but when that car comes to a stop abruptly, if he's not wearing his seatbelt, he will be ejected from the car. This video link, which you can click on if you're watching on, or if you download the notes, just shows you a magic trick. So there are all kinds of magic tricks that you can do where you flick a card and a coin will drop into a cup, and it's all based on objects at rest wish to stay at rest, and objects in motion wish to stay in motion. So let's look at some free body examples. So let's use a free body diagram to explain why a computer sitting on a desk will remain at rest. So if we draw our computer, it has a normal force and it has a force due to gravity. Those should be equal. So Fn equals Fg. And if that's the case, and there's no other motion, there's no applied force or anything like that, then that computer is not going to move. So let's look at a hockey puck that's moving across a smooth ice surface. So when you see smooth ice surface, you're going to assume no friction, okay? So sometimes you're told that there's no friction. Sometimes you're going to have to make that assumption. Okay, so that means that there's no friction. So let's draw our hockey puck. We have a normal force. We have a force due to gravity, and those are going to balance each other out. Okay, so again, they should be about the same length, but if you're ever unsure, you're just going to write a little statement. And then we have our applied force. And so our applied force has nothing resisting its motions because we are saying that it has no friction. So that means that hockey puck is going to keep moving forward. It should travel at a constant velocity until it hits something. So if it hits the boards or another player's stick, at that point it will change direction. So we use this law to help us figure out some other forces. So in this diagram we are looking for our F1 and our Fg. And it's telling us that it's at rest. So that means that our forward force and our backward force should be equal. So to figure out F1, it has to be equal to 1,400 newtons plus 600 newtons. So we get 2,000 newtons. And we're going to say, though, that that's forward. Okay? You can use east, west if you'd like, but I'm going to say that these numbers are backwards, so our F1 is forward. So that has to be in the opposite direction. And our Fg has to equal our Fn. Again, it's going to be in the opposite direction. So Fg is equal to 1,200 newtons, and that's going to be down because the normal force is acting up. So make sure you are putting your directions in because those are vectors. So that's just a quick review of Newton's first law of motion. Be sure to read this section in your book for some of the other theory that's behind it. And also feel free to watch some other videos. But we've looked at how to calculate our net forces and draw free body diagrams.